Hello everyone, my name is Eduardo Silva and welcome to the Fluent Bit presentation at Cloud Native Open Source Virtual Summit China 2020. On this presentation, we are going to talk about logging, data management, and a bit of data aggregation in common database. So Fluent Bit is a tool was designed to fix and work around all the problems and challenges with data. And the whole point of logging and data is that we need to be able to extract value from them. But one of the main problems is that data is everywhere. So if we aim to concentrate all this information, we have a few challenges to deal with. For example, data comes from the operating system, system services, user space applications, and if you are in the embedded world, we have remote hardware, we have sensors, and so on. So how we can solve this problem as just with using one tool or one simple solution? As I said, data is one thing, but if we are not able to extract value from it, it's useless. We have many users just extracting data, but if we cannot perform the right analysis over it, extract value becomes hard. When data is ingested or aggregated in one place, it aims to provide easy ways to perform this analysis and, of course, extract this value so we can gather the insight from it. So you realize that data is important, but if we cannot extract the value, it's a problem. But from the technical perspective, we have a couple of challenges. One of them is that data comes from different network protocols, maybe from TCP, UDP in different payloads, from file system, from systemd, journald. In general, this is complex and a mess because data is everywhere in different formats and from different channels. If you think about just one simple generator of log information, like a hardware or a software, this generates a record. That record gets into a central place so we can do analysis. But if we have a couple of them, this kind of scalability gets more problems. So how do we perform my analysis faster enough? It doesn't matter if I'm collecting more data from different places. So the logging tool here is really relevant because one of the things that we want to avoid is latency. We avoid that the things get delayed. So data comes from different formats. And when I say this, I'm saying that imagine the Apache logs. Apache logs comes with a normal message that you and myself can understand, right? That MySQL, I can understand it. But if you pass this information to a computer, the computer will just see an array of bytes, and that's it. But we want to perform some kind of data processing over this data so we can perform fastest queries or perform a fastest analysis. So one of the key concepts here is to be able to convert this array of bytes to a structure where we have this notion of key values. For example, Apache logs has a timestamp, has a method, URI, HTTP protocol, and so on. Data comes from different sources. We need to also convert this data from a structured to a structured way. And sometimes we need to enrich this data with extra information. For example, if your data comes from different servers, likely you want to enrich your records with the host name, with the IP address, or something that adds more in context to that information. And at the end, we want to send this data out to a central place for further analysis, like databases or cloud services. And this is Fluent Bit. Fluent Bit is a project that was created to solve all these data problems, all these challenges where we have different data channels, different formats, and so on. Fluent Bit is a proud sub-project of the CNCF under the umbrella of Fluentd. Fluent Bit was created around 2015, and originally it was created for embedded Linux. On that moment, we envisioned that we have Fluentd, which was running on most of the major servers of the world, but we are going to need something more lightweight that can run on constrained environments. But quickly, people from the cloud space started using Fluent Bit because they needed something lightweight than Fluentd for some special cases. And Fluent Bit evolved as a cloud space solution too. But it also can run on embedded environments. And as I said, it's under the Apache license 2.0. Fluent Bit is fully written in C language. It types for low memory and CPU footprint. It's running barely can run in 600 kilobytes, but of course, if you are processing more data, you will need a bit more of memory. And it has its own pluggable architecture. We support more than 60 plugins between input, filters, and outputs. And it also has built-in security for TLS and network I/O. When you think about logging, you have to think about this like a pipeline. We have an input and an output, but in the middle, we have different steps or phases for different things. We have an input to go, where we say, hey, from this place, we're going to collect the data. We have a parser section where we can say, hey, we're going to process the data from this unstructured format to this format, right? A structured format, for example, unstructured to JSON or something like that. But note that we don't use JSON internally, we just use a binary version of it. We have the filtering phase to enrich data or remove any content that we don't want from it. The buffering section for data persistency, and of course, routing to send the data out to any cloud database or service. So right now we're going to jump into demo. So I'm going to switch here, just 1 second. Okay, so right now I'm in terminal. So the demo will be about how to run a Docker container. And this Docker container will start an application that generates or simulates Apache log messages. These Apache log messages doesn't have a real format, but our goal will be to take them and process them with Fluent Bit. So first, I'm going to start Fluent Bit in my terminal. And I'm going to start with one configuration format file, that I'm going to explain its content right away. This Fluent Bit service is listening for messages on the TCP port 24224. And right now we are going to run a Docker container, which is called expert Apache logs. And basically what it does is just to generate dummy messages to the standard output. But as just happened some seconds ago, we were running this with the Fluentd driver. Fluentd is our parent project, and the Fluentd driver aims to send this data to a central place. It could be a Fluentd or a Fluent Bit instance. So right now, all these container log messages will be routed back to the Fluent Bit that is running in the second pane on the left. And this is interesting. As you can see, at the top, we have just an array of bytes, but then we can see a structure like JSON at bottom. So let's do some analysis on how this is working. I'm going to show you the configuration that we're running. Basically, we are saying collect data from an input, which is a forward input protocol, filter this data, apply a parser. Do you remember the pipeline? And this parser is saying, take this unstructured data, apply the Apache parser on top of the log key, and reserve all the remaining data. Finally, put this data out to the standard output. Okay? So, but this is pretty easy, but let's also apply JQ so we can see how the records looks like in a better way. As you can see our records, if we format the JSONs, you can see that we have the host, the user, the method, all the data that at the beginning we didn't know about it, but after applying a parser, we were able to show all of this in a reliable manner. Not just show, but also store this data in a different way that can be used later for data analysis. Okay, so that is one use case, right? We just took container logs, we shipped them out to Fluent Bit, and we are showing the data to the standard output. But we want to do something more fancy yet. What about if we send the same data back to a database like Elasticsearch? So I have prepared here a configuration file that is pretty much similar to the first one. But now, instead of sending data to the standard output section, we are sending the data to the Elasticsearch service that is running locally in my machine. The ES name means the Elasticsearch plugin, and we are going to use the logstash format. Okay, So again, we just start Fluent Bit and we just switch the configuration file. And then we just run again our container that is generating logs. And of course, we are not going to see anything on Fluent Bit output because we are redirecting all the logs to Elasticsearch. And here in the other tab, we are going to watch how the messages are being ingested to the Elasticsearch service. If you can look carefully, we have one index which is called logstash. And the number of documents count is increasing, 25, 27. It's shipping 1 or 2 per second because we just have that rate of data. While we keep this running, we can also explore our data with a Kibana. Kibana is a visual way to play with all the data content that we have in Elasticsearch. We are going to start exploring this data. Okay, first of all, we need to create an index pattern. Okay, I'm going to the next step. Sometimes Elastic and this or Kibana, this part is a bit tricky, but we will see if it let us to see all the content. Okay, perfect. And we will start looking at the data. We're going to visualize the data. Oh, sorry, here. Okay, here we go. So our data has been ingested in Elastic, and as you can see, every record, it has its own structure. We can take a look at the JSON format that is coming in. So if you remember carefully at the beginning, we just had one array of bytes, but after a parsing, we get a full structure, we got a timestamp, and we got different information as an addition that was like a context. I'm talking about the container ID and the container name. So this is one of the things that you can do with Fluent Bit. Of course, this is a demo. This is a very simple use case, but there are many more things that you can do. So we are going to get back to our presentation. And okay, so after this demo one, we're going to talk about a little bit about the login basics. This how it works internally. Basically, one application generates a record, which is a message, right? But this record is not just a message. It also comes with a timestamp because it needs to know when this message was generated, plus the message. Internally, we do this, but we serialize all the data that is coming in Fluent Bit with a format which is called message pack. Consider message pack like a binary JSON, but on steroids. And of course, all of this inside Fluent Bit. Fluentd also does pretty much the same thing. Actually, Fluent Bit data processing model like this is an exact copy of Fluentd. Internally, when we have the input sides, we can have many inputs, many filters, many outputs. We have the data that is coming in associated with tags. So with tags, we can say this data is coming from this place, and we want to create then a match rule to say, please send this data out to a different destination. So in the left, we can see that we have two sources of data with different tags, right? One for the Apache logs, other for syslog information. Then we have an intermediary phase, which is like the buffering or storage. And in storage is where we are storing our data. Basic, of course, by default is memory, but also we can put a secondary system in the file system. So if anything happens, like a power outage or a network problem, at least we can recover almost all the data that was at that moment being processed. After that, we have the router. So the router basically takes every input of data that has a tag, and using the matching rules defined by the output plugins, we can ship this data out to different places. Elasticsearch, InfluxDB, or any cloud service provider platform. Right now, we have more challenges, right? It's pretty cool to take the data from one place and ship it to the other, but what about distributed environments like Kubernetes, where every pod can be 1 or 2 or 3 containers, but we can have many pods in one node, and we can have many nodes, but also nodes need to be in correlation with the master API server, which provide context information for every pod. So Fluent Bit comes to the rescue. It basically is deployed as a daemon set, and this daemon set, what it does is to read all the container log files, because by default, this can be changed, but by default, most of Kubernetes distribution store the data information into the file system, but also you can configure Fluent Bit to use systemd or any kind of protocol. You can read the data from the pods, and then Fluent Bit is able to retrieve all the metadata from the API server. But finally, to be able to ingest data back into the database. So the same demo that we did is pretty much the same thing that will happen in a cloud environment. And now we're going to talk about a different topic, which is called stream processing. Maybe it sounds familiar for you, but stream processing is just the ability to perform data processing while it's still in motion. But you can say, hey, we are talking about logging, and now we're talking about stream processing. If you think carefully about logging, what we did at the beginning when we are converting data from unstructured to a structured format, we are doing data processing. But also, we went beyond that and implemented stream processing capabilities on top of Fluent Bit. So think about this. Every record or log message is an event. The events already has a structure. And we had two things, timestamp and message, like this, right? This is an example, temperature and a timestamp. Those are keys and values. And now you start thinking about, hey, this sounds like internal representation of data in a database. Could be. But also, in stream processing, there's a couple of challenges. All the data has different formats. Even if it has a structure, that schema is not fixed, right? It could be different. You can have records with 10 keys, others with 8, and maybe not all the records will have the same name for the keys, right? So how we can do stream processing or provide the ability to process this data in a more powerful way, which is not just filtering, but something that we can run queries on top of this data that is flowing through Fluent Bit. So the stream processing goals are just fast data processing, trying to do it without the notion of tables, no database, no indexing, or index-free, and ideally we want to do it just in memory. So it's just ability to process your data while your data is in motion, meaning it's still in memory, flowing in the pipeline from one point to the other. So how do we do this? This is the traditional way to do stream processing. You have the hardware, you have the events, the data gets into a stream processor, and then you ship the results out to a database. Okay, so this is really good, but if you have a stream processor, you need to deal with the events, the records. You need to expose a query language because you want to do key selection, filtering, aggregations, event routing, and all that things. The traditional model is that if you think about the edge of the cloud, when I'm talking about the edge, I'm talking about where the data is being generated. It could be anything, Kubernetes node, an embedded device, right? The normal approach is to have on the edge something that kind of centralized data, send it to the stream processor to the cloud, and then we centralize the results in a database. Okay, but what we are doing with Fluent Bit, it's more fun than that. Actually, we are doing logging on steroids. We are doing stream processing, but on the edge. In the same place where Fluent Bit is running, you can defer what you used to do in the cloud. Maybe you can do 50% or 60% of that processing, but on the edge in a lightweight mode. This is the regional mechanism that we have, right? From the edge and send the data to the cloud to do all the stream processing. But now, what we are achieving in Fluent Bit is an internal and built-in stream processor that can do analysis, data forecasting, create streams of data. And maybe for you, this sounds familiar to Kafka KSQL. And yes, it's pretty much similar. And what are the goals and features with stream processor? Well, actually, we can offload computation from the servers to the edge where the data is being generated. You just can send the results that you care about to the cloud and not send all the data. Imagine that you have 50 servers. You don't want to send all the data, just a fraction of them. And our query language is SQL. And I'm sure that you are familiar with SQL. And yes, there's no tables, there's no database. It's just Fluent Bit with our built-in SQL processor integrated in our core. And what you can do with the stream processor, we don't have enough time to make a demo right now. But actually, the things that you can do that are really fun is like create a stream for data that is flowing, for example, from an input plugin, tail, or forward. You can say create a new stream using a query, meaning like select all the keys that matches a certain criteria and create a new stream of data. And that new stream becomes a new input of data inside Fluent Bit. And you can route that everywhere. So you can imagine that you can create alertings, you can create special functions to try to detect anomalies, which is quite powerful. The same pipeline that we had now, but instead of normal buffering, we have the format storage. And after storage, we hit the stream processor. And the stream processor, then we hit back the information as the input. Because that data that you're generating is new data. It needs to go through the pipeline and can go to a different destination. We support aggregation functions. So you can create aggregation windows and calculate aggregation and apply the common functions like max, min, sum. And also we support the basic of machine learning functions. We have to support time series forecasting. We did a webinar a few days ago, so we will share the links during this presentation where you can watch more about this, because this is really good, and I think that the future for stream processing, Fluent Bit is playing a major role on it. Now, an example, how you create a stream. Imagine that you're running the input plugin, which is called CPU, which collects CPU metrics in Fluent Bit. You can say, hey, select the average CPU consumption from stream CPU during a window tumbling of 60 seconds. So during 60 seconds, we are calculating what's the average of the CPU that has been recorded. And after 60 seconds, we just ship one result, right, that is created with a tag called results. So you don't ship all the 60 samples out. You just ship one per minute. And Fluent Bit nowadays, I will say that's getting a lot of traction, and the team, we are really excited about this. Nowadays, in last week, we hit just more than 100 million deployments just on the half of this year. So most of our users, I would say 90% are Kubernetes users. They use Fluent Bit with Fluentd in conjunction, or sometimes it's just Fluent Bit. But the adoption is just crazy. And also, we are pretty happy to be working with many companies that are using Fluent Bit in production, like ARM, AWS, Google Cloud, LogDNA, Sumo Logic, Lyft, and so on. And I'm sure that many companies in China are using it too. And we welcome every company, every user of the community to join us and help to make Fluent Bit better. And now we are going to open the time for questions. So I'm going to stop the recording for now for this presentation. Thanks so much for attending this session. And we are really happy that we can engage and receive feedback from you if you are a Fluent Bit user or if you want to jump into it. Thank you. Enjoy the conference.